We have briefly touched on electronic models before in previous videos, but let's now look at these in slightly more detail. There are two types of model which I'd like to highlight. The first is a block diagram representation of a complex system, which just shows the layout of a circuit in terms of its functional blocks. The purpose of this is to simply show how individual circuits connect together to form the overall result. An example is shown on the screen of a radio receiver. The function of the individual blocks should be familiar to you from earlier videos, even if how they work together isn't yet. The second type of model is the one I'd like to say more about. This is the circuit level model. Some circuit devices behave in mathematically complex ways. This is particularly true, although not exclusively, of semiconductor devices. You might remember that even a simple diode is governed by an equation with exponentials, which is shown on the screen. Although we can use such equations to work things out, it's complex and time-consuming to do so. One way around this is to replace the complex device by a simple circuit which behaves in a similar way, and we can use this to do calculations. Typically, this circuit, called the model, consists of simple passive components, inductors, capacitors and resistors, along with current and voltage sources. You must remember when looking at these representations that one cannot make a diode or a transistor with such components. This is just a way of thinking about its function in simple terms to do calculations, and there are limitations of this approach. In particular, firstly, the model is often inaccurate because it cannot or doesn't take into account the subtle second and third order effects present in the real device. Secondly, because a real device is non-linear, i.e. it has complex mathematics like exponentials in it, the model usually is only accurate for a single value of current and voltage. Models can be made more accurate by adding in components to simulate second and third order effects. But remember that the model exists to make calculations simple, and this may defeat its purpose. At high frequencies in particular, the sign becomes more complex because of the parasitics, and so models sometimes exist in low frequency and high frequency forms. Similarly, some models have AC and DC forms, showing how the circuit appears to an AC signal and to a DC one, respectively. We most often use calculations from a model to indicate ballpark figures, so that when we do simulations, we can be confident that the answers given are correct.